Okay, I'm going to do some demonstrations. Look where we are. We're in my room. I got special permission to come in. So let me show you a few things about our next topic, which is electricity and magnetism. So we're going to start talking about electricity. Where did that word come from? Electron, the Greek word electron. What does it mean? I wonder if I've got some here. Let me see. I do. I have some electron. I have some electron with a 35 million year old spider in it. Yeah. Electron actually was Greek for amber. It's petrified tree sap. You know, like Jurassic Park with the mosquito in it? This one's a spider. So why in the world would electricity be named after petrified tree sap? Well, because people used to think it was pretty, amber, you know, this goldy looking stuff. They polish it up, you know. This isn't amber, this is glass actually, this is silk. But they polish it up and it would do wondrous things. Like for example, I don't know if you can see that. I'm not sure you can see it anyways, little bits of paper. And people would polish their amber up. And their amber would pick up little bits of paper. Maybe you can see that, maybe you can't. So that's where it got the name. Now I'm going to show you something. Here's the oracle of power. It's actually called an electroscope. And whatever electricity is, it tells if you got the power. So let's see if we do. Got the power. Okay, I'm going to run through a series of little demos here. Let's see. First of all, I do that and it leans out. If I touch it, it's still got the power, however that thing works. So let's see here. If it quit swinging back and forth, it's got the power. I can take the power away. How about that? Actually, if I give it the power again, it swings around so much. If I give it the power and I come along with more power, it leans out even more. So it's aware of the presence of something. Yeah, the mere presence of this thing. I'm not even touching it. Now I touched it. Now I have more power on there. And yet I can take the power away. Now, what if you're rubbing up your big old piece of black rubber with wool? Does that have the power? Let's find out. It does. Also stinks. It's got the power. I'll leave some power on it. Ooh, definitely got some power now. Okay, so it's got the power. And I can come along with more. Wow, I think it bounces around a lot. What happens if I come along with more? It leans out even further. Now I'm going to come along with the first kind of power. Let's see what that does. Will that add to it too? Wow, just keeps bouncing. Did you see that? It's not the same. Look what happens when I come along with this power. It makes less, and then back to more. And for that matter, if I take that away and charge it up with this one, get a bunch of that on there, and I come along with, oh wow, it's just swinging back and forth so much today. I wish the thing would damp out. Let's see, come along with this one. Makes less. Apparently, there are two opposite kinds of power. Now, you might know this video I am unfortunately making on my iPhone because I messed up my camera app on the computer, so I got to kind of hurry a little bit. We need a little story for how this is going to work. Now, I'm going to go ahead and cut to the chase and say, you know what? The deal is there are two opposite kinds of things. This is kind of why they say that, positive and negative. And I think you've heard the rule before, like opposites attract, likes repel. Positive attracts negative, negative attracts positive, but positives repel each other and negatives repel each other. So how does this even work? The way this electroscope thing here works, and I'm gonna draw it kind of big up here, is it's got a big old, great. It's got a big old frame. And the frame doesn't really do much of anything other than support, this is the part that counts. There's a piece of metal that comes down like this, and some goes over like this, and some comes down like this. There's a little pivot. There's another piece of metal free to swing here, and there's metal up here. Metal is a free path for charge, whatever that is, to move on. So to start the story, you might say that if you put some positive charge on here, let's just say, I'm not sure that's exactly what you're doing, but if you put positive charge on here and they hate each other, they run all down through here, they get all over this, they get all over this, they jump all over the place, and these hate these, they hate them, so it repels and it goes out like this, just get as far away as they possibly can. That's the story. The same thing would happen if I had negative charges that I put on there. If I put negative charges on there, they do the same thing, because they hate each other too. The part that doesn't get explained by that is, why is it that if I'm merely, so look, no charge on there. See, it's all neutralized, no charge. If there's no charge on there, then why would the mere presence, proximity, not even touching, why would that do it? My analogy would be that this thing was like a desert island, and I put some positives that hate each other on the desert island and they repel, and that explains stuff. But how do you explain any action when it's not even touching? They can't even jump off the boat onto the desert island. So how does that work? Well, the idea here is that maybe it's not really a desert island after all. Maybe metals actually contain both. You see, everybody's happy as long as there's positives and negatives, positives and negatives, positives and negatives all over the place. Any hate is compensated by love. And basically, there's no real reason, when there's equal numbers of positive and negative, for anybody to lean anywhere. But if you come along with a boatload of positives, all these negatives go, hey, did you hear there's a bunch of positives on a boat? Let's go get a better look. So the positives run up here, the negatives, run up here to get a better look, leaving their frustrated, abandoned positives back home where they can hate each other and make the thing swing out. And of course, the same story goes if you got the negatives coming along in a big boat. The big boat of negatives comes along and the positives all hear about it and rush up to get a better look. Oh my God, look. And they leave let's see, if that were negatives, the positives leave the negatives at home, and the negatives hate each other and make the thing lean out. So we kind of have a story going here of how neutral objects, things that don't have any charge, actually do have charge. They got equal amounts of positive and negative charge, whatever that stuff is. And so we have just accounted for all the behavior you've seen so far. Now, another thing. You saw earlier, I took this. Let's say this is positive. It's the first, I'm not sure it is even, but let's say this one's positive. I took the positive and I found that it attracted these little bits of paper. So I'm supposed to ask you, if this is positive, what are those? And you're supposed to say negative. I would hope you'd say negative. You'd say that those were negative. And then I would ask you, if you were here and there was anybody in the room besides me, I would ask you to predict what should happen when this is established to be the opposite. This is the light side of the force and the dark side of the force or something, or positive and negative. You should predict what should happen if I approach these, you know, hey, let's see again, this was positive, it attracted those must be negative, right? Okay, so if I come on with negative, it ought to, if you were here, you'd say repel, I bet. Let's try it. What the heck? It attracted them. These things are attracted to both positive and negative. What are they? Well, I'll tell you what, there's just positive and negative, so how's that going to work? How do you get something that's, I don't know, neutral maybe, to be attracted to both positive and negative? Well, looks like I got to draw another picture up here. Is this the marker that works? No, that's not the marker that works. This is the marker that works. Yeah. Okay, so how's that going to work? Well, we've got, say, a piece of paper here that's presumably got some positives and some negatives in it. And I come along with a big old positive thing, and I have to explain how in the world that thing got attracted to that. Well, you could say, oh, look, the negatives, they're attracted, aren't they? But that doesn't do me much good, because the positives are repelled. And you might say that, okay, maybe the negatives are attracted more than the positives are repelled. Apparently so, but why? Why would they be? All right, in the interest of getting right to the point, not making you guess too much, you know what? Maybe these charges are a little bit mobile. Maybe they can move around a little bit and shift around. Maybe it's like it's in a boat, it's a rowboat, and the positives are trying to paddle with their little oars away, and the negatives are trying to paddle towards it, and that ought to be balancing out. But no, if you hate somebody, you're trying to get further from them. So maybe the positives run off to this side of the boat, and the negatives are over on this side of the boat. In which case the repulsion is acting at a greater distance than the attraction is. Now, there's nothing you've learned so far about this that would make that solve our problem. You have to bring in another assumption, and that is that distance matters. Now, you might have heard the phrase, distance makes the heart grow fonder. I've known of people who weren't the same year graduating as their significant other who went off to college, and distance didn't always make the heart grow fonder. But, and nor does it here. Distance doesn't make the heart grow fonder. Distance here makes it grow much, much weaker, because now what's happening is this repulsion, this hate, is very muted. It's not a very hateful hate, you know, because it's kind of too far away to really care anymore. Not as much. But since these are closer, this is a stronger love. And there's a net attraction after all, because the ones who didn't like you anyway got further away where it didn't matter as much. The ones who did like you snuggled up where, oh, now they really are attracted. Because apparently this is one of those things where the radius, or the distance matters. Remember with gravity, we just learned the law of gravitation, just did that. It was F sub g equals g m1 m2 over r squared. We learned that. All of a sudden now we have something extremely analogous. There's this stuff called charge. The letter for charge is going to be Q for quantity of charge, I guess. I suppose that's where they got it. And we're going to be talking about an electrical force. And distance is going to matter. And distance matters. The way the universe is put together is so neat. There's like a theme going on. You know, with gravity, it was an inverse square law, you know? So inverse square means there'd be an r square on the bottom. And instead of masses being the thing that matters, it's charge, Q1 and Q2, two charges. That's the idea. There's a charge Q1 and a charge Q2. They're separated by a distance r. And they either love or hate each other with some amount of force. Oh yeah, how much? This much, except it's got to have constant. Now, I'm gonna get more numerical about this in another video, but this is so much like this. This is why we're learning about electricity hot on the heels of learning about gravitation, because somebody's got the same idea going on here, the same sort of cosmic law that acts. Now, I've just accounted for the behavior you've seen, but you know I ain't gonna turn this video off without doing that thing. I hope it's not the last video I ever make. Gee. Okay, here goes. This is gonna hurt me more than it hurts you, obviously. Its hair's standing up. What about mine? I don't know. Let's see. I'm feeling it. Oh God, I'm feeling it. I don't have anybody to. Oh, there's nobody here to touch. Dang it. Let's see if I got the power. Oh God. Yeah, it's popping. Oh yeah. Do I have the power? Whoa. Now I've got the power. What about the little ones? Are they attracted? Yeah, not quite. Oh, there you go. There you go. Yep. Gosh, I'm going to maybe touch something. That one down. What's, okay, I'll get down off this. It's gonna probably hit my toes pretty good. Okay, lights off. Let me cast offerings upon the great one. Oh, please accept my humble offering. Oh, rejecting my offerings. It's rejecting my offerings. Sometimes it accepts them. Let's see. I'm starting to smell ozone in this room. It's getting intense in here. Come on, take it. Oh, there we go. Sometimes they'll like go back and forth. Hold on. Here. Oh, come on. Ah! What else we got? That's what it is. Oh, yes. Animal sacrifice. Rabbit fur. Can you see it? It's going all over. You can see it. Okay. I better turn this off. Get real ozone in here. Ow. One more time. Okay, yeah. We've been ionizing the air in here or something. We've been creating ozone, knocking the atomic oxygen to pieces, and then one of the oxygens goes join us with the other and makes ozone. And this thing's still got the power. I'll take it away. All right, I'm gonna make making this one on my cell phone. I'm gonna make another video later with more explanation of what the heck you do with this stuff. But you've just seen basically how this electricity stuff at least kind of looks. And purposes of the next video, I might want you to guess how many volts was involved there. There was this thing called an electric potential difference. It can be measured in volts. You've heard of volts. Maybe you've heard batteries of volts. Maybe you know how many volts the outlet over there is supposed to have, or whatever volts do. You might wonder how many volts that is. Another video, I'll tell you. Anyway, yay. You got to see the room. Got to see the Van de Graaff generator. Talk to you later.